Is there a pause?
We've been pausing.
Okay.
You know, we did one that's 3 hours long. It's kind of, and I don't know what the limit is on watching it on YouTube. I don't think they let you watch 3 hours at a time.
I don't know. I haven't watched the videos. I just flip through the slides once in a while.
Okay, well, it works. You just don't get to hear me. Okay, we're going to talk about signals and emissions, and then the second part will be antennas and feed lines. There's, I think I explained before, there's 10 sub-elements in the technician and the general, and there's 35 groups of questions. So each one of the sub-elements has anywhere from 2 to 6 or more groups associated with it. You only get one question per group. That's why there's 35 questions on the exam. So this signals and emissions is going to cover 48 questions out of the pool and 4 groups. So it will be, I mean, 4 of these may show up on your exam. Well, 4 of these will show up on your exam.
Yeah, Aaron said he's could be a little late.
Oh, that's not working again. Come on. Another technical difficulty. Okay, so talk about modulation, which is the process of adding information to a radio wave. If you just generate an RF signal, there's really no information there other than its frequency. So one of the first things they did to convey information was to start using Morse code or similar things. So they turned the carrier on and off. That's a very crude amplitude modulation. It's either 0 or 100. When we get to some of the newer stuff, they started experimenting with frequency modulation, where you vary the frequency proportional to the modulating signal's amplitude. There's also a phase modulation where they vary the phase of the signal, and it's very hard for humans to detect a phase change, but electronics can do it. You only see that in some of the more the digital modes where they're using phase shift keying. And again, it's in proportion to the audio or digital signal that's modulated. And the different, you know, FM radio or receiver can detect the change in frequency. They use something they call a discriminator. It's a little more complicated than just it's detecting an amplitude, where all you need is an envelope detector, which is kind of it's a low pass filter and the diode. Here's a picture of comparing an amplitude modulated carrier and a frequency modulated carrier. You can see how the frequency changes. In this case, the frequency goes higher as the amplitude of the modulating signal goes lower.
Another participant. Another participant?
That's what I thought, but I don't see anybody. Okay, question number 1. Which type of modulation is commonly used for VHF and UHF voice repeaters?
Okay.
I didn't explain it well. Roger. What's your pick?
D. I would say D.
Delta, good.
Okay.
Frequency modulation for handy talkies and repeaters. Supposedly PM, I haven't seen any that use phase modulation. Most of the handy talkies and repeaters that I'm familiar with are all frequency modulation. Okay, packet radio is a way to send digital information, and they send packets of bits, marks and spaces to represent the digital signal. So they send multiple bits at a time in what they call a packet. And they use FM or PM for VHF or UHF. It's just changing the frequency. And they started calling the ones and zeros marks and spaces. So a mark would be 1200 hertz, and a space is 2200 hertz. So they use the two different frequencies, which makes it easier to detect. You just need to be able to recognize one frequency or the other. Now, some of the newer digital modes, like FT8, for instance, which is one of the most popular ones, uses 8 tones, 8 frequencies to represent a 3-bit combination, which has 8 states. So you're basically sending 3 bits at a time for every one of their characters. Okay, what type of modulation is commonly used for VHF packet radio transmission?
Okay, I'll pick A this time.
Roger.
Yep. Same.
Amplitude modulation. This varies the amplitude proportional to the voice. Now, there's a special form of AM called single sideband, where in order to decrease the bandwidth so you get more power concentrated in a smaller frequency range, they eliminate one of the sidebands and the carrier. And I think I have a chart coming up to show that a little better. And this is what's normally used. In fact, it's the predominant AM for amateur radio. You get the most distance for voice, single side.
Yeah, you can spend extra and get even a CB radio that has that feature. Which you got to know who you're talking to on the other end, or they have to know what band.
Well, yeah, they have to be able to have a SSB receiver, and they have to know whether it's upper or lower. Which of the following is a form of amplitude modulation?
B.
We hadn't talked about spread
C.
spectrum, but that's it's kind of hard to describe, but it's more of a frequency modulation. It's actually multiple frequencies, and it's a digital thing. Your cell phone uses a spread spectrum type of modulation. Radio control airplanes and boats and stuff use, most of them now use spread spectrum.
Old ones used FM.
Right. Single sideband is actually a form of amplitude modulation. Phase shift keying is not. Why single sideband is in there, I don't know. Because it is. Yeah, packet actually is frequency, the 2 tones, or more than 2 tones. Normally, the packet stuff is sent as mark and space. Okay, which type of voice mode is often used for long distance or weak signal contacts on the VHF and UHF bands?
Slide.
D.
FM has about a 12 kilohertz, 15 kilohertz bandwidth. Single sideband is 2.5 to 3 kilohertz. So it's much narrower bandwidth, which is why you get more energy per hertz, so you can get further. Okay, single sideband can be upper or lower. When they first started, they tended to use a 9 megahertz intermediate frequency. So it was easier to generate a lower sideband signal when you were operating on a band below 9 megahertz and USB above. So that sort of became a convention. We use 10 megahertz as the sort of reference today. So anything 10 or above is normally upper sideband. Anything below that is typically lower sideband. However, it's just a convention. So USB is 20 meters through VHF, UHF. I guess if they're using single sideband at the gigahertz stuff, be there too. And the 160, 80, 40 are all typically lower sideband. And even the newer 2200 and I think it's the 630 or something, low frequency stuff, which they're starting to do now. At least that's what I'm playing.
Navy.
You need an awful long antenna. Here's a picture showing single sideband. Start off with your baseband signal, which is your audio that you're going to modulate the signal with. Now, in this case, it's showing most of the energy down here, obviously male, and most of the energy is down in the low frequency part of it. One of the things you do on single sideband is use some voice compression, and you shift that towards the upper end and get more power under the curve. So when we modulate it with standard AM, we get that signal shifted up in frequency, okay, by whatever your carrier or your local oscillator is. So you see that over here is this upper sideband. You get a mirror image of it as a lower sideband, and they're separated by whatever the intermediate frequency is, and then the carrier in the center. So you get a frequency shift of a plus and a minus against the carrier. Now for single sideband, they use some techniques filtering to eliminate the carrier and one of the sidebands. So when you transmit upper sideband, you just see this part. So you still have 100 watts in this instead of 100 watts spread over all of that. Likewise, lower sideband is the lower one. Which sideband is normally used for 10 meter HF, VHF, and UHF single sideband communications?
B.
Hear you.
B. Upper, really? I'm talking more.
Yeah, 10 meters, not 10 megahertz.
Oh.
Remember, 10 meters is 28 megahertz. So it's higher than 10 megahertz.
Yep.
Okay. Audio on FM sounds much better than AM if you listen to AM radio versus FM radio. Basically because it has a 12 to 15 kilohertz bandwidth, whereas typical AM radio is about 6 kilohertz. So you don't get the highs, although at my age, doesn't make a difference. I can't hear them anyway.
Me either.
When you do single sideband, you can really tell the difference, especially if you're not perfectly tuned and you get a Donald Duck effect or like a rain barrel. It's not high fidelity, but it's intelligible. So single sideband for the purposes of the exam is 3 kilohertz wide. AM is 6 kilohertz, and FM, standard FM is 10 to 15. There's also a narrow FM, which is, I think, 6. That's not on the exam. What is the characteristic of single sideband compared to FM? I'll give you a clue. It's definitely A.
I don't believe it either. I'll pick Charlie.
Yeah, Charlie or Delta.
Yeah, Charlie, because A is not true.
Oh, that's true.
And SSB signals are not less susceptible to interference than FM. In fact, that's one of the reasons to use FM, because they're not susceptible to amplitude modulation noise, which is what most man-made noise is. Okay, what's the approximate bandwidth of a typical single sideband voice signal?
3?
Bravo.
3 kilohertz.
Bravo. What's the approximate bandwidth of an FM voice signal?
See, 10 to 15. Yeah.
He said 10, 15.
Disadvantage of FM compared to single sideband is only one signal can be received at a time. What they mean by that, if you're listening to AM or single sideband on a radio, if you've got two signals that are very close in frequency, or even on the same frequency, just one may be 1,000 miles away, you'll hear both of them at the same time, even though, you know, one distorts the other. It may not be easy to tell which is which, but you can hear more than one at a time. With FM, it has what's called the capture effect because of its frequency modulation, and the discriminator will only pass the strongest signal. So on FM, you will only hear one signal, unless you're way down in the noise and just getting garbage. Which of the following is a disadvantage of FM compared to single sideband? Roger?
One at a time?
Okay. Yep. Voice quality is definitely not poorer on FM. And FM signals are not harder to tune. They're easier to tune. So all these choices are correct, can't be correct. Okay, some modes have very wide bandwidths. AM fast scan TV is approximately 6 megahertz. We refer to that as NTSC, or the National Television Standards Committee. Now, I think it's since changed, but that's what the ARL is using. It's a reference for analog fast scan, which is what your TV used to be when it was over the air. Now, there's also an amateur slow scan TV, which one of the guys at the NASA club has been doing a lot of. What's the approximate bandwidth of AM fast scan TV transmissions?
6
Hmm.
megahertz.
B,
6 megahertz. What type of transmission is indicated by the term NTSC?
yeah, I'll go along with that.
Charlie? All right.
Yep.
Okay. CW or continuous wave is another name for Morse code. If you look at the band plan charts and stuff, they all just list it as CW. But I've not seen any kind of CW that isn't actually Morse code. They have a very narrow bandwidth compared to the rest, approximately 150 hertz. As a technician, you have CW privileges on 80 meters, 40 meters, 15, and 10 meters. Plus CW privileges on everything VHF, UHF, and above. All you have to do is learn Morse code.
Again,
Well, it shouldn't be too hard if you knew it.
I did one time.
How many words did you do?
What was the novice? 15?
Well, I think you only had, for novice, I think you only had to do 5.
Yeah, 5, that's right, it was. Well, I made it up to 15, I think, when I took it.
Yeah, I think for general or whatever the one was in between, I think it was like 12 or 15.
Yeah,
That's why I didn't do it. I couldn't do the code.
it took me a while, but I got there.
Yeah, I haven't been practicing. I was getting pretty good. I knew all the letters and numbers, but I can't receive them very fast.
Yeah, I did really bad on numbers.
What is CW?
Carrier wave.
Another name for Morse code. Which of the following types of signal has the narrowest bandwidth?
CW.
CW.
CW, right. 150 hertz. What is the approximate bandwidth required to transmit a CW signal?
Nice segue.
Yeah,
150.
150, right?
Morse code can be sent with a straight key or a paddle. What did you use, Roger?
I actually started out on a straight key and then I went to paddle later as I got quicker.
If you're not familiar,
I haven't personally touched. I've seen them. I haven't
Okay.
touched.
straight key is just a single set of contacts, and normally it's a vertical. You push it down and makes contact, and does a
Yep.
get or a dot depending on how long you hold it. A paddle is normally horizontal
Back and forth.
levers or whatever, and you normally have them, and you can reverse it, but you have it set up where you push one, it gives you a dit. You push the other, it gives you a dot.
Yeah,
And
it's
it
long.
goes to a keyer, which will repeat. So if you hold one, it will give you dit,
Oh, I see.
which is why it's,
My paddle never did that.
oh, well, the paddle itself doesn't, a keyer does.
Yeah,
You plug the paddle into a keyer, and some of the newer radios have a keyer built in and will do that when you use the paddle. And
Well,
you
I'm
can
talking-
tell it,
I'm talking back in the 70s. We didn't have all that hot stuff.
well, there was keyers. Maybe you didn't have one. It was a separate box.
Yeah, I didn't have one.
What is an electronic keyer?
System.
bunch of weird things. I'd say C.
Right. Okay, digital modes. Allow us to send digital data as opposed to voice or some other sort of analog. Packet radio was one of the first digital modes. 802.11 IEEE standard is for Wi-Fi, which you use all the time, and that's a digital mode based, and it's actually a packet mode. It sends packets of information. FT8 is probably the most popular of the newer digital modes. It was developed by Joe Taylor at Princeton, and he got a Nobel Prize for doing some weak signal stuff. And he developed these protocols that FT8 is based on in order to detect satellites and stuff at, you know, astronomical distances. Very, very weak stuff. Moon bounce, one of the modes in the WSJTX software, which is a suite. It has about 6 or 8 modes like FT8, FT4, JT65. There's the MS. I think it's MSK 144. Bunch of different ones that are all weak signal. The interesting thing about the moon bounce, we have a guy in the NASA club that does that. The path loss to the moon and back is 250 dB. Now, remember your dB stuff. That's a lot.
Yeah.
So you start off with the maximum of 1500 watts, and that's going to give you about 62 dBm. You maybe get a 20 dB antenna. So now you're up to 80. And I guess you get to count the antenna on reception, so another 20 out of it. So you got 100. You still got 150 dB down with all of that. He said, you get on there with voice. Hello, moon. Hello, moon.
Yeah.
Okay, PSK31 is an older, and this one actually uses phase shift keying as opposed to an FM. FT8 uses what they call audio frequency keying, since they're low frequency tones. And PSK31 is a teletype type of mode where you actually, on each end, you type, you know, it prints out the message and you type one in. APRS is the automatic packet reporting system, which some of these modes can also send, and they can also include GPS data. So there's some apps like PSK Reporter that you can bring up when you're running some of these modes. And because it's sending APRS information that picks it up, it's kind of a worldwide thing. And you see a map and you see every place that reported that they heard your signal, which is kind of cool.
Yeah.
Okay, a computer is required, at least so far, to modulate and demodulate the digital signals. Now they're getting to the point where some of the more modern advanced transceivers can basically do this all in one little box. But most of them, you'll still require a computer or at least a cell phone.
I would imagine those transceivers probably already have a computer processor built.
Well, yeah, I mean, the SDR ones basically have a computer of sorts, microprocessor, maybe more hardware dedicated, done with FPGAs and stuff. Okay. Which of the following is a digital communications mode?
All are correct
FP.
today.
Yep. Every once in a while, there's an all these are correct.
Yeah,
Okay, packet radio sends messages as packets. So if you have a long message, it's going to get divided up into however many packets it takes to send that message. Because packets are usually fixed length. So one of the fields is actually the data field. So that determines how many bits they can send per packet. Because you'll have a header on it, and you'll maybe have a checksum or CRC at
Some
the
sort
end
of corrector, yeah.
for error correction. Packets can go to multiple destinations, and they can be broadcast, or typically they're sent to a single destination. There's also a store and forward mode. I think that's mostly with satellites, where you can send to a packet to a satellite, and then when it gets within range of wherever the destination is, it can forward it on. There's also ground stations that do that too. Some of the RAC will do forwarding, so you can send a message and it will store it forward later. It's kind of like leaving a message on your phone. Okay, you send the message and it's stored on a node somewhere until you actually come and read the message. The header of the packet will contain the destination address. In ham radio, it's usually the call sign that you're using. It wouldn't be a call sign if it was 802.3 or Wi-Fi. It's going to be your MAC address, an IP address, and then the packet also contains some form of checksum, and the receiving station will typically send an automated repeat request or an ARQ. So when they get the packet, if they can't decode the packet correctly, so the checksum doesn't add up, or if it's got some other error detection, they will send back an ARQ which says resend the packet. There's a typical packet structure where you got some sort of sync, which you need in order to decode the bits. Different frame headers. The actual data is in this field, and it's got some sub information headers and checksum and stuff in there. And then there's an overall checksum or a Reed-Solomon code, similar to Hamming.
are they still limited to just 64?
Say that again?
Is the data packet still limited to just 64? I thought it went up from there.
Well, in this particular one is 64. It depends. I mean, different packet telemetry types vary. Let's see, Ethernet, I used to know all this stuff, was I think 1,080
Yeah,
characters.
1024.
Well, there was some additional header and stuff on there.
Yeah,
Okay, which of the following is included in packet radio transmission?
Second.
again, it looks like all the above. Yeah,
Okay. Some systems use a special protocol to get error-free communications using the ARQ, where you have them resend the packet is one of the protocols. So there's a checksum sent with each packet, and if the checksum doesn't add up, the receiver sends the ARQ, and it will do it n number of times, and that's a programmable thing. You can have it set for like 3 or 4 or whatever, and at that point you give up, you don't get a connection.
I was gonna say, it probably slows it down if it keeps getting an error.
I mean, because it could go on forever. I mean, if you got a really bad link, very weak, noisy signal, you may never get it.
Error
Yeah.
show up.
If I remember right, it creates what's called a storm, right?
Okay, what is an ARQ transmission system?
I see Aaron is up there.
What?
I see Aaron waiting
Yeah,
right at the top, at least on the screen.
Okay. There you go. You there, Aaron?
yeah, I see where Aaron, there he is.
He has arrived.
Can you see us? Can you hear?
Yeah. Okay.
Okay. Well, I'll back up. Okay, we were talking about packet radio and some of the special modes, like the automated repeat request, where the receiving station, if the checksum doesn't add up, they send back an ARQ message which says, resend the packet. So what is an ARQ transmission system? Aaron?
Correction method.
See,
Yeah, I'd say C.
Everybody's right. Okay, APRS is the automated packet reporting system. Some of the digital modes will also, like FT8, for instance, can send APRS information. A lot of your mobile radios and handy talkies can be set up to send APRS also. And a lot of them have a GPS receiver, so they'll send your location information. And there's receiving stations that can detect that and send it to sort of a central location. And I was just telling them about Packet Reporter Info, which is a website you can go to, and it will show all of the APRS info that it's collected, and you can put in your call sign, and it will show every station within however many hours you asked it to that has received your signal. It doesn't mean that you've contacted them, but it says that they're reporting that they heard W3RDL, and it'll be color coded based on the band, use different color for each band, and it's a whole worldwide map. It's kind of cool. And it goes, I think you can go back the last either 12 or 24 hours and see stuff. The APRS stations, like your mobile and the talkie, can also send some text or weather information. And you can get one of these real-time tactical maps similar to the Packet Reporter info site. We used it at the, it was November or December. There was a T-minus 10-mile run out at the Cape that we supported. And we had somebody on the lead car and somebody on the tail car with APR. And one of the runners was one of our club members. And he had his handy talkie set up to do APRS. So we could track him during the race and where the lead and tail cars were real time.
So he didn't have to do any keying or anything. It's
No,
just the radio
just
was
have it on.
automatically.
It's automatically broadcasted. It's a low data rate, periodic. I forgot how often it sends.
So it's kind of like one of these that
Yeah.
you can.
And you probably, I don't know, might be able to do it with your phone. It's similar to this, some of the tracking stuff for your phone anyway. Oh, there's a picture of, in this case, it's Whisper, which is similar. It's a weak signal propagation reporter map. But it looks very similar to the Packet Reporter info. Okay, which of the following is an application of APRS?
A.
Roger?
Yeah, I'll go along with it.
The key thing to remember when you see this question is the real-time tactical and the map. What kind of data can be transmitted by APRS?
All of the above.
We're getting a lot of these.
All of them.
All these are correct. Okay, PSK 31 is popular on HF. It's a phase shift keying technique. 31 represents 31 baud. And also it turns out it's 31 hertz bandwidth. So it's one of the narrowest of the signals. FT8 is 50 hertz wide. This one's 31 hertz wide. So it's good for weak signal stuff, although it doesn't use the same techniques as FT8 and 4 and those. So I think this just uses 2 tones. I'm not sure. I haven't really played with PSK 31.
I imagine if you're squeezing your power into that narrow of a bandwidth, you can reach out quite a ways.
Yeah. And it uses what's called varicode. So instead of the typical where you would map your ASCII characters straight into binary, it changes the mapping so that you minimize, and all the characters won't have the same length. So the most frequent characters, like your vowels, will be the shortest,
Little ones.
and the ones that you hardly ever use will be the longest codes typically. I don't know if I have a chart showing. I guess I didn't put it in there. Okay. What does the abbreviation PSK mean?
B.
B.
Phase shift keying. Okay, digital mobile radio, or DMR, is one of the digital voice modes. There's DMR, D-Star, and Fusion. I think there may be some others, but those are the major 3 by the different manufacturers. Even though they're all supposed to be open source, there's some parts of them that aren't. So digital mobile radio kind of came from Motorola some of their older commercial stuff, and I don't remember who now picked it up, but most of your Chinese radios, your Baofangs and all the different clones and stuff, if they have a digital voice radio, it will be DMR. ICOM uses D-Star, which is done by the Japanese Amateur Radio Society, supposedly an open standard, but the only two people I'm aware of is ICOM and Kenwood that do D-Star. And Fusion is done by Yaesu. And I don't know anybody else that does Fusion but Yaesu. And ICOM and Yaesu are the two big radio manufacturers outside of the Chinese who copy everything.
Is anyone any better than the other?
Well,
Yaesu-
you're getting into the religious wars.
Ah,
I mean, there's ICOM converts and there's Yaesu, and hard to say. I mean,
Yeah, I had a
you go
Yaesu.
individual radio basis. This one might be better than that one, but not because it's an ICOM or a Yaesu. It's just a better radio.
okay.
And they, when one comes out with something, the other one, if it doesn't have an equivalent, will have an equivalent and try to make it cheaper or better.
Okay.
It's the typical. Okay, so the one thing that DMR does that the others don't is it uses time division multiplexing. So you can have basically two subchannels going. I've yet to understand the great advantage to that, but that's the main difference, is that you can have slot 1 and slot 2. And when you program the radio, you can set up the slots separately. DMR allows communications over multiple repeaters interconnected via the internet, and so does D-Star and Fusion. And they all work through a repeater or a hotspot that gets connected to the internet and there's gateways, so you can go. Actually, now with some of the gateways, you can go between DMR and D-Star or All-Star or Fusion. Things are all getting lumped together on the internet, so you can just about get anywhere if you can figure out how. In DMR, those interconnections, they call them talk groups. So when you join a talk group, you're only going to communicate with other people that have joined that particular talk group. Doesn't matter where they're at. Could be anywhere in the world, but they're connected to that talk group. In D-Star, they call them reflectors. And I don't really have any Yaesu stuff, and I don't know much about Fusion, but I'm sure they have an equivalent thing. Okay, which of the following describes DMR?
A.
Yep.
That's their big takeaway. Because that's the one thing that makes it different than the other two. Otherwise, it's digital voice. What is a talk group on a DMR repeater?
B, I think.
Did I hear you say Bravo?
Yeah.
Okay, that works. Yeah. The group of operators don't have to have a common interest. They just have to join the talk. Okay, digital modes. WSJTX, which I talked about before, developed by Joe Taylor for deep space communications. It supports some of the modes like Earth, Moon, Earth, or Moon Bounce, Meteor Scatter. There's one called MSK, I think it's 144, which which they developed to do meteor scatter, which we'll talk about a little bit later, where you can actually, so they tell me, bounce signals off of the meteor trail because it leaves an ionized trail. But I guess you have to know when it's coming and be in the right spot, cross your fingers. It also supports WSPR, or weak signal propagation beacons, and they send out periodic signals, and you can have beacons on. They're really all over the world, broadcasting on different frequencies. So one of the things you can do to tell about propagation is try to listen to some of these beacons, and if you can receive their signal, which is very low power, then that's a pretty good indication that propagation is good between you and wherever that beacon is. It has the following modes: FST4, FST4W, FT4. I've never tried those. Or excuse me, I did make about a dozen contacts on FT4 last time. FT8, JT4, JT9, JT65, I've tried, nobody's there. Q65, MSK, which is the meteor scatter one, and Whisper. And actually, I don't know what Echo is. But of all of those, FT8 is by far the most popular mode. It's called FT8 because it uses 8 low frequency audio tones to represent the binary data. So in effect, it sends 3 binary bits for every character that it sends. And it's 50 hertz wide. So it's very narrow bandwidth. Which of the following operating activities is supported by digital mode software in the WSJTX software suite?
We're hitting all of them today.
Wow.
In
Yeah.
Delta.
That's what, 4
Or 5.
or 5?
Yeah.
What is FT8?
B.
Doesn't do any multiplexing, and it's not slow scan TV.
Okay.
Mesh networking is a popular amateur radio activity, so they say. I don't know anybody that does it, but somebody must, because it says so in the ARL book. It's an amateur network where they take commercial routers, basically, modify the firmware, and build their own private mesh network. And you can get commercial.
PN.
Oh, there you are.
I see him moving.
Yeah, I'm back. We disappeared for a minute there.
Yeah.
I think we must have had the internet drop out. It's getting pretty dark out.
Lightning strike.
Yeah, I've got a very large thunderstorm over top of me right now.
Okay. Can you still see my desktop?
Yes.
I can't see your desktop. I could just see you, but I'm in Amish country, so maybe someone moved their wagon.
Pennsylvania?
Yep.
Oh, let's see. The east. Share it again.
That's not it. To the left.
There it is.
Yeah, all right.
Yeah,
Now we're
we-
cooking with gas.
Yep.
Okay, like I said, it's modified commercial, equipment, usually routers and or access points where they use some modified firmware. I don't know any more about it than that. It uses the same, Wi-Fi bands, the 2.4, 3.4, and 5.8 gigahertz. Most of your Wi-Fi stuff and cell phone stuff is either 2.4 or 5.8. They can support high-speed emergency communications. Of course, that's assuming that the internet is actually working. There's, I guess, a couple networks, the broadband hamnet and the amateur radio emergency data networks that are out there. I don't know any more about those either, but I don't think that's a question. We'll see. Which of the following best describes an amateur radio mesh network?
Hey,
Modified firmware, commercial hardware.
Yep, we just went blank again.
Well, yeah, we got to the end.
Oh,
But why did it say screen sharing stop?
still recorded.
it's probably because you hit the end of the presentation there.
But I'm surprised it stopped the screen sharing, but whatever. So I guess it's time for a break. What time is it? 10:30.
10:30,
Sorry, about an hour.
speeding right along.
Yeah.
So going back to FT8, once we colonize Mars, is that how we're going to communicate with the base station over there?
Who knows? The problem with FT8 is it doesn't really send any information other than you send your call sign and your grid square, and then do you exchange signal reports, and then you do a 73 and log it. So there's no other information that really gets sent. Whereas something like JT65, I think you can actually send some other information. There's one called JS8 Call, which I've used, which isn't part of the same software suite, but it's based on the FT8 type protocols. And it's actually a message passing where you type in a message and you can direct it to a specific call, or you could just do a CQ with it. It works pretty good. It's not fast. It's fairly low baud rate, but it works pretty good. I guess you could, as a tech, you should be able to use that on 10 meters. And I don't know if anybody there, you could use it on 2 meters and 70 centimeters, except you're talking line of sight, so you're kind of limited in who you can talk to. But I don't know how we'll communicate with the moon. With Mars, I don't keep up with that. I'm not sure I'll live to see people on Mars.
I don't know. It seems to be happening faster than we think, so you never know. We'll see what Elon Musk pulls out of his hat there.
Well, I'm afraid Elon is shut down for a while. The FAA didn't take kindly to him not being able to blow up his rocket.
as expeditiously as he should have.
Well, he didn't do it at all. I mean,
Which one is it? Which one is this?
They managed to poke us a couple small holes, but it didn't destruct. So
That was the one that launched out of Texas, right? That was the one that went down over the Gulf.
Yeah.
So
He's got a lot of work to do before he gets a approval to launch again.
well, he was one of the first that came up with the automated command destruct, right?
Yeah, and
It didn't destruct like
it
he
didn't.
thought.
Well, the automated part worked, but the destruct part didn't work. Apparently, it went off. But however, whatever they plan to actually, what you need to do is relieve the pressure. Okay. So you
Right.
have, and I guess it just made some very small vent holes, which didn't do much.
Well, that vehicle was stainless steel, wasn't it?
I don't know.
You're talking about the one that he hopes to launch into deep space, the big boy, is that whatever it's called?
Yeah.
It's not the standard Falcon, it's that big thing he's trying to build.
Right.
Yeah, I think he's built it out of stainless steel, I think. And that's
Exactly. It's got a stainless steel skin on it.
They got enough smart people. Now it seems like a bonehead mistake, but whatever. So,
yeah.
from what I understand from some of the insiders around here, he's got some work to do before. It may be next year before he launches that again.
Yeah, well, I give him credit for being ambitious, that's for sure.
Oh, Aaron, are you familiar with any video editing?
Light video editing. I'm not great at it, but yes.
Well, I want to be able to go back and break these videos up into smaller pieces. What do I need to do that?
So you're used to using open source software. I know you're not a big Microsoft guy for obvious reasons, but Microsoft comes with video editing software built into the Windows system. If you're on Windows 7 and up, I think.
I was looking for stuff, and there were comments about that one sucked.
Well, it's not very user friendly, but it works.
Okay, but all I need to do is, cut them apart, separate them.
Yeah, and that'll do that.
It is all full of bells and whistles for transitions and all kinds of special effects. I just want to do a simple cut in pieces.
Yeah, the Microsoft one will work fine for that. I'm pretty sure Adobe's got it as well. I got to look.
Probably
I was going to try Blender tonight, which I'm kind of familiar with, but I've never tried to do video with it.
Yeah, the simple if you're just doing simple cutting, the Microsoft one will do fine.
Is that included as a freebie?
Yeah, it's part of it.
Five.
No, I'm pretty sure it's included. Let me see if I have it on mine. Yeah, there's a video editor included, and there's also Microsoft. It's called Clipchamp, which you can download for free.
Clipchamp?
Yeah.
Okay.
I haven't used that one.
All right. Well, let's see. I should have stopped this.